All right. So we are transitioning to a digital SAT, but regardless of whether or not you are within the paper or a digital, the math section still is the most important part. And why is that? Because the SAT is, gosh, it's not here. Anyway, the SAT is not really the score is not really scored in a linear scale. So it's not like if you are correct, you have 10 correct answers, you will get 10 points, or 9 correct answers, you get 9 points, or 8 points, vice versa, anything like that. It's scored with, it has an evaluation process. In the paper SAT, they will evaluate the test based on its difficulty. For example, I took the August SAT, which had one passage. Yeah, it was a literary passage, and it was about Moby Dick. It's a very famous novel in American literature, but it was very difficult. So someone ended up losing 3 questions and still only lose 10 points on the SAT. And in contrast to some easier tests, for example, on the very beginning of 2018, I believe, they can lose up to 10 points per one wrong question on the reading section. And to stress how tough that is, the reading section tends to be the section that most people make mistake at. Why is it? Because obviously it's difficult, regardless of paper or digital SAT. So how are we going to combat this? How can we score high if the digital SAT or the paper SAT is not scored in a linear scale? We can find it quite a bit more difficult to sort of get more scores, right? But here's the thing, because it is not scored within a linear scale. Moving away from the Zoom whiteboard so that you can see this a bit easier. If you can't see this, tell me, because my screen is relatively big, so it's going to appear quite small on your screen. Anyway, it's not scored within the linear scale. So this is going to be our priorities. Firstly, we were going to learn maths. We're going to perfect maths, not to learn maths. We're going to perfect maths, and then we're going to perfect writing. And then to, reading, of course, the last section, reading. Why is this? Because if you lose one question on the math section, you may even lose, one question, one wrong, you may even lose 10 points. That is very severe. And if in contrast, if you lose, for example, 2 questions, you may only lose 10 points. That is the difference. That is the very difference. So if you lose, minimize your errors on the math section, and the same thing goes for writing section, because they are relatively easier than reading, because maths and writing, not everybody is good at maths, but most people are. So the SAT would assume that you are good at maths, so they would subtract more from you if you are to make mistake in the math section. But the new SAT is a bit different, because they would combine these 2 sections, and they will have one math section. The old one would have a calculator and a no calculator section, but the new one, it only has one section. It is called maths, but it's divided into 2 modules. But you can use your calculator in both modules, and it might be a good thing, might be not. I don't know, depending on you. But still, things, they stay the same. Maths still is the easiest part on the SAT. So you lose the most points. That's the contrasty thing. You lose the most points in maths, and you lose the second most points in writing, and then you lose the last most points in the SAT in reading. Many people, they would focus on fixing what they are their weakest point, right? They try to fix their reading. For example, they add level, they add 8/10, A of 10, A from 10, a 10th. They add 7/10, and they only add 3/10, and they try to lever this up to 5/10. and they keep these relatively the same because, to be honest, reading is very difficult to increase your score or increase your skills. So they would not have enough time to increase these two skills, these two aspects. So they ended up, well, increasing the score on the reading. So they only increased for like 10 or 20 points. In contrast to if the student B, who is not this guy, who is smarter, who is way smarter, who is way more strategic, and he improves this to a 9/10. And this will be to an 8/10. Only this will make this student miles ahead of this student because he will improve even 100 points on the SAT. That is how insane that would the SAT would serve you if you don't know what it is testing. So I'm going to put an emphasis on maths for this week, for these beginning weeks. I posted this for you to see. So the first stage we are all in is the first week and the third week, from July 1st to July 16th. We're going to learn about grammar punctuation, the easiest part of grammar, which is like plug and play. You don't really have to learn or make any advanced assumption. You should just learn by heart everything and then just plug and play. And maths, you have to finish everything in maths for the first 2 weeks. And stage 2 is a bit of more advanced grammar. So you make a bit more inferences, you make a bit more in-depth questions and answers. And yes, introduction to reading. So you can see that we haven't learned reading yet until 18th of July. That is a slight change in our class for this session, for this season, because I would put the emphasis on the math section and the writing section before the reading section, because you most likely not improve reading at all on its 2 weeks of learning. On only 2 weeks of learning, you can't do anything about reading because it is a build-up skill. But by writing, by practicing writing, you can improve your reading in parallel because you must read when you write, right? So that the same logic applies. You must read in order to improve writing. So it can be, it's just marginally improved, but it's still an improvement comparing to if you prioritize reading in the first place. So recap, focus on maths, 100% on maths, and like, no, not 100%, 75% on maths, 25% on writing, because writing punctuation, you only have like one punctuation left is comma. You only have that one left. And so put the main emphasis on maths. And the next one is about homework. So An asked me about homework this 5 a.m. in my local time. And luckily I wake up early and I gave him the homework and gave everyone homework. But this is how we'll work. Because today's session, because I haven't sent you the schedule yet, so you might not have known. But today's session is about maths. So next section, this night or this morning, I will send you homework in maths. And then the next maths section, I will fix it. And the next writing section, I will fix the last writing homework. So I only fix the homework about a section when there's in the next section, in the next session about that section, right? So you got it. If I were you, I wouldn't get it. If you got it, it's great. So that's about our homework, right? So that's basically it about our little bit of chitty chatty introduction. And yes, we still have grading policy because I still grade you on Google Classroom via Google Classroom. And so please be careful when you're doing your homework. I will give out deadlines later. But if you ask for more homework, I would be gladly to give you more. All right. Today we're going to learn about maths. These are the topics which we'll learn about. Firstly is triangles. Let's jump into triangles. Let me create more pages. Hang on a bit. New one. Duplicate. Okay. Today we're going to learn about geometry. Geometry is the field in which you can improve so very quickly, because on the SAT you only have a handful of geometric shapes. Firstly is circle. Next is triangle. What's next? Rectangle. And volumes. Volumes. These are the thing that you have to put your emphasis on, and I'm going to focus on, because the SAT focuses on that. All right. Firstly is circle. Circle is, everybody knows what circle is. It's this. This is a circle. So it's a round in what's the language of maths? In Greek? Is it Greek or anyway? Triangle, is 3, so there are 3 angles. 3 angles. So it's a triangle. And rectangle, rect is 4, so it has 4 angles. This is a rectangle. This is a rectangle. This rhomboid shape is also a rectangle. This parallelogram is also a rectangle. So in this section, the rectangle, you have to learn everything about the naming, mainly the names. And yeah, rectangle, they only have names to the most important thing about it is names, because the what is it? The formulas, yeah. The formula is not really difficult. And last one is volumes. Volumes is just these 2D shapes, and you just scale it up on its height. All right. I'll show you what I mean later. First, so the first one I will teach is about triangle. Triangle requires the most marks because it has, firstly, trigonometry. Do you know what trigonometry is, An?
I know what it is, but like I haven't like officially learned about it yet.
Do you know the 4 trigonometric names?
No.
All right, so a bit of introduction about trigonometry. Firstly, can I ask about it for you, Hung? Do you know what trigonometry is? Trigonometry. In Vietnam, we've all learned this. Everybody's learned this, and trigonometry. I'll give you some clues, okay? It is some mathematic equations that is specialized for right triangles. Trigonometry. Can you guess it?
Yeah, I do know it. I just didn't know the English word.
All right. Trigonometry is, well, these are trigonometric names. These are trigonometry. In Vietnamese, it's lượng giác, and everybody knows that, right? In Vietnam only. But in America, I believe it's just an early introduction to trigonometry in 9th grade. And in 10th grade, you will learn the basic trigonometry in right triangles. And in 11th grade, you will learn a bit more how to calculate trigonometry in using calculator, and all beside the special angles. And I will talk about special angles later. So trigonometry is basically something you're going to have to take in mind when it comes to right triangle. And something else, if I give you a right triangle, what would you think about? What one more formula would you think about? Can you tell me? Can you just name one formula that comes up with in your mind when I talk about right triangle?
A square plus b square equals c square. I think that's
yes.
There's something theorem. I forgot the name.
Okay. It's in Vietnam. In Vietnamese, it's quite similar to in English. It's Pythagorean theorem. It's a very special theorem which we use all the time on the SAT. It's like language. It's like using English. It's very common on the SAT. So as Hung has mentioned, it's a squared plus b squared plus is equals c squared. And this is hypotenuse. This side of a triangle is a hypotenuse. These are the legs. All right. These are the legs. And this is an angle, a right angle. Why is it called a right angle? Because it is 90 degrees. Okay. So you can spend some time noting it in. All right. So when it comes to right triangles, yes, it is a whole problem on its own. It is a different section within triangles, because triangle itself is just a simple shape. But when it comes to right triangle, it is still a simple shape, but it has more formulas to it. So this is you don't really have to remember the name. You just need to remember the formula. But everybody knows the name of Pythagorean. Pythagorean. He's a very famous Greek philosopher, maths, and is he an artist? I don't remember if he did art, but he's a great philosopher and mathematician. And he came up with this, and it's basically the fundamental of triangles or Euclidean geometry. Euclidean is basically 2D geometry. And next up, if you've finished copying this, I'll move to another part. Next up is enough introduction about right triangles. I'm going to talk about triangles in general. Triangles, they are not only right triangles, there are different types of triangle. Can you okay, now I will give you the first type of triangle. The triangle which has every side of it with an angle smaller than 90 degrees. So let me just suggest you this. This is one type A. It has less than 90 degrees. This is type B, which we have mentioned already, 90 degrees. And this is type C. Has one angle that has a value of more than 90. This is less than 90. And let's see. How do you call this? This is acute triangle. In maths, you just need to know the definition. You don't really need to know the everything, right? But you just need to know the definition. This is the right triangle. And this is an obtuse triangle. All right. Have you got it noted down, An?
Yeah.
All right, just to make sure. All right. When I give you 3 different triangles, you would think about, what's the relationship between these 3? So they don't really have any relationship, all right, because they don't look similar. They don't have the same shape. They don't have the same angles. They don't really have the same height or same width or same every side, the length of every side. So, but if I give you this? No, not this. two triangles, but one just seemed like it's zoomed out, right? It seemed like it's someone stretched this little triangle into the bigger one. What do you call it? Anyone knows? Anyone knows what is it called?
Oh, is it scale factor?
No, I'm asking about these the relationship between these triangle.
Is it a congruence triangle?
All right, about congruence, and yes, you're talking about pointing at the right direction, but it's not congruent, it's similar. All right, similar. So you've just mentioned congruence, and I've crossed out one option for you. Can you explain what congruent triangles are? If it's not similar, this is similar, and what are two triangles if it's congruent to each other? Can you give me the definition?
So
Hung, can you do that for me?
are they identical?
Yes, identical. They have the same what? They have the same what?
Length, height, and every angle is the same.
All right, that's correct. So do you know how to prove if they are the same? You only need to have what?
You need either three angles of the same value or three sides. Or you need to prove three sides has the same length, or two angles one side and two sides one angle, right?
Yes, correct. So the first one you've mentioned is three angles, which you corrected yourself quite quickly. Is well, yeah, the first one is not really correct. So that's so good that you corrected that. The first one you mentioned is the very special case of similarity in triangles, because if a triangle, they have the same angles. For example, these triangles, they share the very same values of angles, but what makes them the same length is the size, right? So if I am just comparing about the angles, I can't really make sure that they have the same height, the same width, the same hypotenuse. I can't make sure of that. So how can I be sure that two triangles they share the same height? I'm gonna have to prove one more side. So I just only have to prove two. For example, this is a normal triangle. This is not a right triangle. This is an acute triangle. I only have this. These are the two acute triangles, and I'm proving them congruent. I'm proving them congruent. I'm going to have first, either I'm going to have to prove two angles and one side. Two angles, one side. How can I prove that? These are two angles, and these is one side. The side is in between the two angles. Okay. The next step is if I have two triangles and they share the three same sides. They share the same length on every side. They are similar. And if I have one angle and two sides, they are still equal or congruent to each other. So in summary, you have three ways of proving: two angles, one side; three sides, one angle, two sides. These are the three ways. And how can you prove if two triangles are similar to each other? So you're going to have to rely on the angles, right? So you only have to prove two angles they share the same value. Angle A, B, C. A, comma, B, comma, C, comma. And if I am to prove B and C is equal with B, comma, C, comma, this is the definition, this is the theory of the inner angles of a triangle. Sum of all inner angles, or all inner angles add up to how much? Do you know, Lina? Do you know this? Can you fill in the blank?
180 degree.
Can you repeat that a bit louder?
180 degree.
Yes, correct. 180 degrees. So why am I putting this in inner angles? Do you know what an inner angle is, Lina? It's how it sounds, right? It seems like it's precisely that, because math is very logical. There's no trickery in naming stuff. Inner angles. So the angle has to be,
Inside the
yes,
rectangle.
correct. It has to be inside the triangle. All right. So how do you call this angle? There's a red angle. This is inner, and how do you call the red one?
Right?
Yes, the outer angle. And based on this, can anyone give me how much is C1 plus C2?
180.
Correct? Because if a straight line is separated by a different line, is cut by a different line, they will add up to 180, or a different segment. So this is a new word for you, a segment. If I am to stumble upon any new words or new definition, I'll teach it to you all, so be sure to know them all. And it might be all over the place, but at least you'll get the concept of it, and at least you'll get the coverage, the coverage of everything, of every knowledge. This is a segment. Segment has a starting point and an ending point. And this is a line. A line is represented by an infinite straight line. Okay, you have to differentiate between them. All right. Lina just mentioned about rectangle. So we are going to talk about the triangles, the rectangles also. The same thing goes for triangles. Let me change the ink back to black. Wait, can't do that. Yes, I can. Let me write it. All inner angles of a rectangle add up to how much? Can anyone give me that, the value?
360.
Yes, 360. So this is too special. This one, for example, this one. These are added to 360, A, B, C, D. So the more you know. All right, I'm going to give you some time to copy them all.
Actually, I just Googled it, and a rectangle turns out to be a quadrilateral with 4 right angle, and what you just drew there, the ABCD is Cambridge says is a quadrilateral.
Wait, a quadrilateral.
Yeah.
A quadrilateral. Let me have a quick check on that. Lateral. Oh, yes. Yes, I made a, thank you for pointing that out. A rectangle, so they are indeed, they need a right angles to become a rectangle. So rect here is actually squares, not four. I got mistaken with quad. Quad is actually four. Quadrilateral. Quadrilateral is basically everything related to the shapes with four sides. And rectangle is just about these two shapes. There's with not a square and a rectangle. Rectangle is a square is a special case of a rectangle. Yes, thank you for pointing that out, Hung. And this is not a rectangle. This is one subsection of quadrilateral. Let me point out the name of it. It is called a trapezoid or trapezium in UK. No, this is not a trapezoid because a trapezoid has a prettier image of it. I'll give you the full one. First one, this is a trapezoid. Because the SAT is in American English, so you should remember the American definition rather than the UK definition. And next is a parallelogram. Parallelogram. This is the easiest to remember because parallel lines, they only have parallel lines. And what else? A diamond, yeah, diamond. This is a diamond, or you can call it a rhombus. Here, diamond or rhombus. Scientifically, they call it rhombus, but casually or colloquially, they'll call it a diamond. And this is a kite. Kite is basically an asymmetrical diamond. Is a kite. It looks like a kite, so I'm going to call it a kite. And you should remember it as a kite. It's very easy to remember. So, all right, the more you know. Hey, I learned something new every day. All right, let's see. What else should... Okay, so we've gone over the relationships between triangles. Yes, we've gone through it, and I haven't proven there's one way left to prove two similar triangles. One way left to prove two similar triangles is if you have the diffraction of two angles. It's a bit unknown. It's like not as common, but I've used this like once or twice on the SAT. So you can have A, B over A comma, B comma is equal to A, C over A comma, C comma. And is equals to B, C, B comma, C comma. You're gonna just need to prove one of these or these two. Yeah, you're gonna have the last one is given because if you are to prove these two, it will automatically stay true with this one. So you're just gonna have to prove one pair, not three. One pair of two, not a pair of three. All right, that's it. We are going to talk about something different. It's about special. It's about trigonometry. Trigonometry. To make sure everybody understands what trigonometry is, because An mentioned he has only been introduced to it. So I'm going to have to walk in a bit deeper. Trigonometry only happens so far on the SAT. They only account for angles in right triangles. All right, angles in right triangles. And trigonometry you have, how many is it? Like 4, 90 degree, 45 degree, 30, 60. Yes, 4 different special angles, which have a very, very good form in fraction. But a bit of introduced to trigonometry. It's just a representation of maths in geometry. I find it difficult because why should you even learn trigonometry when it comes to geometry? Because geometry should strictly be stick to like shapes and sizes, right? But why trigonometry? Trigonometry is basically a way for, just like pi. It's a fraction of the circumference divided by the radius. That is pi. And that is a representation of mathematics, of algebra, of arithmetics in geometry. So when it comes to trigonometry, it stays the same, but it's a bit more difficult because it has 4 formulas to it. Sine, cosine, but people would just say it cos in Vietnam. In also scientific connotation, they call it cos. They write it's cos, but they say it's cosine. And tan is tangent, and cotangent. This is tan. So in full, it's sine, cosine, tangent, cotangent. And in Vietnam, there's a very, very simple phrase to remember what these stand for. It's oh, let me draw out a shape for you first. A, B, C. This is, I'm talking about the angle of A, right? Angle of A. Angle of A. I'm talking about this angle. What is sine of A? Sine of A, I would know that it's sine is BC over AC. Cosine is AB over AC. Tangent is BC, yeah, BC over AB. And cotangent is AB over BC. So based on this, you can see that they are the opposite to each other. So you should only have, you can just only remember the 3 first values. In Vietnamese, there's xin đi học cốt không hư, tan đoàn kết, and cô tan kết đoàn. That is very easy to remember in Vietnamese. But in English, I'll show you this. It's so, ca, to. All right. So, ca, to. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite, and you get the idea, over adjacent. So I would suggest to remember this circuito, and cotangent is just tangent over the power to the power of -1, which is 1 over tangent, which is just adjacent over opposite. It's just the opposite of this. Just flip the denominator and the numerator. And we'll have to remember circuito. Remember to note this down. And the Vietnamese fellow can just remember the quicker way of saying it. Just is like xin đi học cô không hư, tan đoàn kết cô tan kết đoàn. That is quicker and easier to pronounce than in English. So either way is fine. You can remember one or the other, which fits your taste. Different strokes for different folks. All right. Next is some common trigonometry values. I want you to remember this. Common values. What are they? They are sine. I'm going to write it down. It's 30 degrees, 60 degrees. Wait, 45, yeah, no, 60 degrees, 45 degrees, and 90 degrees. In physics, you have something called the circle of trigonometry. This is the circle of trigonometry. This will be the cosine axis, and this will be the sine axis. And this will be startling to a few people, but it's very easy to understand, at least to my taste. It's very easy to understand. Basically, this is a circle with the radius of 1. So this is 0 degree. This is 180. This is in degree, okay? You have something, you have some different values called radians, which we will talk about it later. This is degree. In degree is 0, but in radian it's pi, and this is 360, and this is 2 pi, and this is also 0. Firstly, now there's, starting from 0 angle, you have cosine is what? Can you tell me what is the value of cosine? Do you know the value of cosine? Who can tell me? From 0. This has a radius of 1. So what is this? All right, because this is the maximum of a circle, and it's down, and you point it down to cosine axis, and you can see this has the value of 1. So this has the value of 1. Cosine of 0 is 1. And you move it a bit further to 30. And this is where things get a bit difficult to, kind of visualize. This is 30 degrees. 30 degrees. And it has the value of cosine is square root of 3/2. And when you move it up a bit more, you have 45 degrees. You're going to have square root of 2/2. And move it a bit more, you're going to have, move it down. And if my shape is it looks a bit better, or it's more to scale, it will be exactly in the middle, but I'm not very much of a good artist myself, so it's 1/2. 60 degrees. And when it comes to 90 degrees, which is the top of this, it is 0. Why am I writing this? You might find it difficult to understand, but this is basically just an axis, an XY axis, where the X value is cosine and the Y value is sine. So at point A, I'd say it has the location of A is actually 1, 0, or XY is 1, 0, right? So you get that? XY is 1, 0. So in this simple one, I'm gonna have this space has the length of 1. So this is the A point, and it has the location of 1, 0. So cosine is basically X, cosine is 1, and sine is 0. That's basically it. And this circle is basically, to me, I only use this circle to differentiate, because obviously it seems to you guys that you don't really find it easy to remember this at all, right? This is not at all easy to remember. So how can you remember this differently? Why am I teaching you this? So that you can remember these two values, sine 90 and cosine 90. You see, cosine 90 is this. This is cosine 90. Wait. Wait, sine 90 is 1. Yeah, sine 90 is 1. This is cosine 90. Cosine 90 is 0, right? But sine 90 is 1 because sine is at the y angle, y axis, and cosine is at the x axis. And cosine of 90 is 0 because look, if you just draw down a line to the x axis, you would see that cosine takes the value of, assumes the value of 0. That's why cosine 90 is 0, and that's why sine 90 is 1. Because if you want to get the value of sine out, you're going to have to draw a straight line from the angle to the axis, and you'll see that it crosses the 1 point. And if I am to draw down a line crosses a perpendicular line crosses the cosine axis, it will cross the square root of 2 over 2 point. Basically, I taught you this to remember to not be mistaken the 1 and 0 value of sine and cosine, the 90 degree. But if you want to remember, I would suggest you remember this table, the 45 degrees, the 30 degrees, and the 60 degrees. This table. Firstly is sine 60 is square root of 3 over 2 is cosine 30. So sine 30 is square root is 1/2 and is equals to cosine 60. Sine 45 is square root of 2 over 2 and is cosine of 45 degrees. Sine of 90 is 1 and is equals to cosine 0. All right. So we have a one tiny addition. You can see that sine is basically cosine, but is basically 90 degrees minus cosine, the angle of cosine, right? So if I say sine of A is equals CD. How about cosine? Can you give me the value of cosine? It's 90 minus A angle. Cosine is basically sine angle, but 90 subtracted by, no, is a sine angle subtracted by 90. No, 90 subtracted by a sine angle. So you can see that this is 90 minus 30, and this is 90 minus 45, and this 90 minus 90. That is how you're going to make a relationship between sine and cosine. They share the same. If they add up, the angles they add up, they will add up to 90 degrees. So the more you know. And this is mandatory for me to teach. But if I'm lazy, and if I'm a lazy student, I would do this. I'd use the calculator. And what calculator are you using? Is it a Texas Instrument?
I think so. It's TI-84.
TI-84. Let's see. I believe it has the trigonometry connotation to it, right? It has the shortcut.
Yeah.
Yeah, so you can just let me see the screen. All right, I'm going to share my phone screen to you because Anne uses a different calculator to us. So I'm gonna say this is sine and cosine and tangent. You can just press in sine, and the layout is a bit different, but everything else is the same. But for everyone else, they can just follow my screen. because this is Casio scientific calculator, and this is what most Vietnamese use. You can just press it sine, for example, sine 60. You get square root of 3/2, and cosine 30, you get square root of 3/2, and everything like that. You can see it's very easy because the calculator does it all for us. And remember, there's something called radian and degree, and something called grad, and I don't know what that is, but radian and degree. Actually, this is a different angle measurement, but we only focus on degrees and radian because that is what the SAT measures. And be sure to know whether or not you're using degree or radian, because I believe in Texas Instrument, there's also a symbol to indicate whether or not you're using a radian or a degree. I'll check it and talk back to you later on. But for the time being, you can see that I can just forget everything I just said, and I could just press 60. Even now I do, because sometimes I wouldn't believe myself, especially for major exam like the SAT. I wouldn't believe myself. But remember whether or not to use radian or to use degree, because if you press in radian, you would get a very different value, right? This is cosine 30 of radian. This is a very different value, you see, but this is cosine 30. Wait, let me switch back to degree. Cosine 30 of, see, they have very different values. This is a quite easy to look, but this is quite ugly, right? This is from radian and this is from degree. They're just two different measurements, like pounds and grams in weight, and just like meter and foot in length. They're just different measurements of length of a degree. So it doesn't really matter the relationship between those two. You just need to know that whether or not you're using one or the other, so that you won't make the wrong calculation. All right, so I know it's going to be quite overwhelming to you at first, but maths is very simple. Don't have to fuss over it. You're just going to have to look back once or twice or 4 times or 5 times. You're just going to have to look back on it a bit for a while, and then you're going to get it all through. Because once you do, it'll be very easy to you, because on the SAT maths, it's very simple. Next up, what I want to talk to you about is volume. I want to cover everything, and I want you to immediately jump to the practicing process. That's why I'm crunching up the process. But if you don't understand any part, just feel free to message me. As always, I'm here to help. Now I'm going to talk about areas and volumes. Lina, can you tell me what is areas? What is the meaning of areas? I'm going to give you one clue, all right? This is a length. This is a segment, AB, and a length measures the distance from A to B. And with the same logic, can you tell me what the areas measure in this shape, ABC? When I say the area of triangle ABC, what do I mean by it? What is the value of area? What's the value of area? So when I say when it comes to perimeter, it means the A, B, C, D. When I say the perimeter of a rectangle, A, B, C, D, I'm talking about the sum of AB plus BC plus CD plus DA. So I'm talking about the length of the outer segments. So when I talk about areas, what about that? What does the area measure? Do you know that, Lina? What does it measure? Just make a quick guess.
I can express in English.
Just say it in Vietnamese. Let's see.
Diện tích.
Yes, it diện tích, but what does it measure? What is the meaning of diện tích? So when I talk about the perimeter, it's about chu vi, right? And it's about the length of the outer segments. Chu vi là một cái kích thước của độ dài tất cả các cạnh ở ngoài. Thế thì cái diện tích là gì? What is the area?
Là cái phần ở bên trong cái hình đấy.
Yes, correct. So the area is the measurement of the inner parts of a shape, right? You can't just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 3 dots, 100 dots. So it has the width of 100 dots. You can't do that. But what you're going to do is you're going to multiply the length with the height, and you're going to have an area. So the area is multiplying the length, and basically the length and the width of a shape with some slight modification. For example, this is triangle. And if I want to measure the space in between, inside, that's what you express, right, Lina? I'm going to have to use the height times the width. But this is a triangle. If I use width times height in a rectangle, I would assume that I'm taking the DC part, I'm swiping it up to the height. So I'm having this all covered by DC. See, I'm taking the DC part and I swipe it up. I have the area. But a triangle, look, it has this shape. It is enclosing to B. So what do? I'm multiplying it by 1/2. So the meaning of the area is basically you take the width and you scale it up to the height. You swipe it up to the top. But the triangle, it's not equal on all sides, and it is enclosing on the top. So that's why you're going to have to multiply by 1/2, because the area, just remember this, the area of a square. Square is a standard measurement of most 2D shapes. Square is a squared, right? So you're going to have to multiply by 1/2. When later on you'll learn about volumes. Volumes of a square is a cube, is a cube. So you're going to have to multiply it by 1/3. That is basically how mathematicians come to conclusion that you're going to have to multiply by this, because you see it as a formula, but mathematicians see it as an explanation. They don't just assume that it's 1/2. They don't just, it seems like 1/2 of an area of a square. So they're just gonna multiply it by 1/2. No, they use something called derivatives. No, integral. They use integral, which is a very advanced mathematical maths concept. It's a very advanced maths concept. So they use integral to calculate from point A to point B throughout the length of ABCD or ABC. So it's not just about multiplying with 1/2. It's about using the right explanation, because this square uses a squared, or a to the power of 2. So in integral, let me see if it's integral or derivatives. Integrals 1/2. Let's say in integral or in derivatives, they're going to carry over 2 and it becomes 1/2. And that's how they're proving this. So that's how you're going to remember it. Take the square or the cube as a unit of measurement, and you're going to remember every single shape. So a quick recap, an area is basically you take the width and you scale it up, you swipe it up to the height. And if the shape is not is enclosing or is not equal on all sides, you're going to have to multiply it with 1/2 for with the shape. For polynomials, no, not polynomials, polygons. Yeah, a polygons is basically a shape with many angles. For a polygon, that's how you're going to do it with a polygon. And this is the same with a rhombus. Rhombus, they don't have all sides equal. You can't just take the width and scale it up because these are not equal. So you're going to have to do what? You multiply these parts because this is the width and this is the height, right? And you multiply it by 1/2, height and width. The same thing goes for, say, parallelogram. You draw down the height, and this is the height, this is the width. You multiply the height with the width with 1/2. The same thing goes for parallelogram, for a trapezoid. A trapezoid, but it's a bit more different because the trapezoid doesn't have one width, it has two widths. So you're gonna have to 1/2 and plus, and you add up the two width together with 1 and with 2. You multiply it with the height. And that's essentially every single way possible to calculate an error in 2D, right? So when you take the 2D, you take the error and you make it 3D, what do you get? Get volume. Why is it? Why is it that you take 2D and you get area and 3D you get volume? Because remember, 2D is basically, this is the length, and in maths concept, this is a one-dimensional. This is one-dimensional. When it comes to area, it is two-dimensional. But when it comes to volume, which is a new concept, it is three-dimensional. What is 1D, 2D, and 3D has to do with how you calculate? 1D is represented by a line. So it has the length of a line. 2D is represented by two lines perpendicular to each other. They are represented by two lines. So it has the value of A times B. Two lines, the multiplication of two lines. But when it comes to 3D, it has the length, is represented by three lines in three-dimensional space. So you're gonna have to add up A, B, and C. You see, this is how the mathematicians come up with how to calculate volume. You just take the AB, wait, let me see, there's C and this is B. You see this is AB, and you see this is the original axis, AB, and you flip it down, you add another kind of axis to it, and you get A, B, and C. This is the height, this is C, and you're gonna have to scale it down, scale it up to the C axis, and you have volume. That is how a volume is formed. Take, for example, a cylinder. This is a cylinder. How are you going to form a volume? Volume is basically how you would calculate every single thing inside. Area is the same, calculate every single thing inside, but in the two-dimensional plate. This is in a three-dimensional space. So you're going to have to do what? You take this top or bottom, you do whatever, and you take it and you spread it out on the height. This has the area of S, right? You have the area of S. You scale it up, you swipe it up to the height of H, and you have the volume. The V is S times H. This is the common formula for every shape, S times H. For S is the area of the bottom or the top layer, the first or the last layer. The same logic applies. This is a prism, triangular prism. a triangular prism. This is a cylinder. This is a triangular prism. You do the same. You take this, and you swipe it up to H. And you get a volume. It's basically S times H. But what if I encounter different kind of shape? What if I encounter a pyramid? Do you know the shape of pyramid? This is a pyramid. What do you do then? You see, we encountered the same problem we encountered before with a 2D plate. Look, the triangle, it is enclosing on the top. And the pyramid, they also enclose on the top. What do you do? Can anyone guess? What do you do? What do you do to calculate the volume? If you know that the common formula is S times H for a non-special kind of 3D shape, how do you calculate the volume when it comes to a very special shape like a pyramid when it is enclosing on the top?
You divide it by 3. Just my guess. I have no idea.
All right. So we apply the last logic, which is the area of a square is a squared, a to the power of 2, and we carry the same logic to volume. The volume of a cube is a cubed, a to the power of 3. A to the power of 2, when it translates to other shapes or special shapes, area is 1/2, and a to the power of 3, when it translates to special shapes volume, it will be 1/3. That is correct, because this is a 3-dimensional space, so you're going to have to multiply it by 1/3. 1/3 times S times H. So what is S? If this is A, B,
Sorry,
C,
I was
D.
correct.
Yes, you're correct. You're correct.
I see. Thanks.
All right. This is D, right? This is D. And let's say if ABC in 2-dimensional plate, ABC has this shape. And I have the height. Height is H. This is O. DO is the height. Can you tell me how can I calculate the volume of A, B, C, D? An, can you calculate it for me?
No, it'd be like you'd multiply the length, the width, the height, and then you divide by 3.
Can you be a bit more specific? Walk me through it. You have the formula is V is 1/3 times S times H. But what is S? What is H? I want a specific kind of values to it. How do you calculate S and H?
S is like the bottom, so you calculate the bottom triangle.
This is the bottom triangle. How can you do it?
Base times height divided by 2.
Yes, 1/2 times base BC times height AB. Is it correct? This right? You mean this?
Yeah.
All right. So what's next? I'm calculating V. What's next?
You multiply by height. And
Height
after
is, what is height?
DO.
Yes, DO is height. And then
You divide by 3.
yes, correct. So this will become 1 what? 1/6, right?
Yeah.
Right, that's correct. And you're getting the hang of it. This is how you basically calculate the volume. You just calculate the base area, and you just swipe it up and you times 1/3 if it is a special case, and you don't multiply by 1/3 if it's not a special case. This is a quite an advanced and a very in-depth understanding of what a volume and what an area is. So if you don't understand any aspect of what I'm talking about, please do voice your opinion, because this is very important, and this is how much. Let me open the SAT official. This is the reference sheet, and this is how much you're going to have to memorize in order to do maths quickly. And you shouldn't just memorize everything. You can just memorize how these equations come into term, how these equations are formed. You can just memorize those. The cone is basically the same. You see, this is the cone. And I'm going to talk about one thing more, one very important, very special kind of shape. It is a circle. It is the only shape with no angle. It is the only shape with so many formulas that it has its own chapter for it in the SAT. It is a circle. This is a circle. And the area of a circle, it will be pi times radius squared. Area. This is the area of a circle. And we don't say it's a perimeter of a circle. We say it's a circumference of a circle. C is pi times 2r, or pi times d. Who can tell me what is d and what is r?
Radius and diameter.
What radius? Can you draw a radius for me? How can you draw a radius?
It's like it's a point from the circle to like the middle of the circle. Like
Yes, from a one point in a circle, to the middle point of a circle, correct? And how about a diameter?
it's just 2 radius. Like the
2
whole-
radius. Is this a diameter?
No, it's like it's one end to another, and it has to pass like the middle point.
Correct. So you essentially taking a line crossing a middle point, right?
Yeah.
Yeah. You understood that, right? This is a line. This is a line. If I give the name to A and B, AO and OB, they are what are they called? AO and OB.
Radius.
Radius, but they are essentially segments. And D is a line. And a line that crosses the center point is will form a diameter. You just have to have a line and a center point, and you will have a diameter. And you need a point on the circle and a center point, and you will form a radius. And the relationship between diameter and radius is a diameter is 2 times the radius, right? So next up is 3D circles. How do you 3D a circle? You draw a circle. Wait, this is a very ugly circle. You draw a circle. It's not too pretty, to be honest, but you give it some depth. This is a sphere. You please do remember the area and the circumference, right? I glossed over it quite quickly, but please note. And here comes the sphere. The sphere is essentially a circle in 3D, a 3D circle. You give it another axis, it will become a sphere. How can you do a sphere? Look, how can you calculate the area of a sphere? You still remember the way, right? 1/3 times the something called the base or the area of a base. The area of a base, you times pi times r squared. But this is where things get tricky. This is not at all enclosed. It is not enclosed on the top. It is enclosed on the top and the bottom. So this formula is essentially not similar to every other shapes. That's why circle is so special, because it is the only kind of shape in 2D and 3D that has no angles to it, and it is the most special thing, and it is the most special shape because it is not a polynomials. No, not a polynomial. Polygons. Polynomials is a different one in arithmetics, but it is not a polygon. It doesn't have any angles. So you're gonna have to remember one thing is because you can't do this. You just multiply it by the radius, and you multiply by 4. You can't do this. You just remember this core and you just add them in. 1/3 times the area, which is times r times 4, which is 1/3 times 4/3 times pi times r cubed. See, that's how you're going to remember it. Circle is quite different. Circle is quite special. So this is the only case in which you're going to have to remember things differently, because this is a special case. And there aren't many special cases on the SAT. Right. Speaking of which, special cases, I remember one thing I haven't taught you, which is radians. Radians is especially special when it comes to trigonometry. They only use radians. They don't use on the SAT, they tend to use radians over degrees when it comes to trigonometry. That's why you need to learn how to convert radians to degrees and vice versa. What is radian in trigonometry? You just assume, you just use this, assume this formula. You take degree divided by 180 times pi, and you get a radian. See, not to be mistaken for diameter and radius, degree and radian. It's just a way to convert. Remember this, it's just a unit. It's not something special, just a unit. Divided by 180 and times pi, you get a radian. So, quick maths. Can you give me what is the radian value of 90 degrees? Pi over 2, right? How about 60 degree? Was it?
Pi over 3.
Pi over 3, correct. You just take 60 divided by 180 and then you add a pi to the back. And how about 30? How about 30? Pi over what? Yes, pi over 6. And the last one, rad 45. Yes, pi over 4. This is essentially the 4 special angles on the SAT. And this is the 4 special angles on the SAT for radian. So can you tell me what is cosine pi over 3? What is cosine pi over 3? What is cosine pi over 3?
1/2.
No, it's not. Oh, yes, pi over 3 is 1/2. Yes, correct. How about what is cosine pi over 4? Pi over 4.
1 over the square root of 2.
Yes, it is 1 over square root of 2 or square root of 2 over 2. How about sine pi over 9? Pi over 2. Rapid fire, everyone.
1,
What is it?
1,
1. Yes, correct. So next one, how about sine pi over 4?
square root 2 over 2.
Square root of 2 over 2, correct. This is the same as cosine pi over 4, right? It's very simple. You're just gonna have to check if you remember it instantly. And seemingly you've kind of like 50% remembered it. And let's see, let's review our knowledge for today. And the next tomorrow, Saturdays or the next session, we will review and we will check back the knowledge of today, and we'll do some practice tests and practicing questions and answer. Revision. Firstly, you have to prioritize the maths before writing, before reading, because they will subtract you the most from maths than to writing, than to reading. So focus on maths. Don't let yourself make any mistakes on maths. My aim or my teaching is everybody gets 800 marks before they do anything else. All right, 800 over 800. Every one of my students did so, and I believe you guys can do it too. So practice, 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 and do it well. Try to get an 800 as soon as possible. Next is the right triangle problems. Pythagorean theorem is a squared plus b squared is equals c squared. And with that, we have relationships of triangles. You have two relationships. Firstly is congruence. Congruence is two triangles, they are the same to each other. And secondly is similarity. Similar to similar triangles, they share the same shapes, but they scale differently. One is bigger or one is smaller than the other. They are similar. And two congruent triangles, they are exactly identical. They are the same. And next is the sum of inner angles and sum of outer angles. And remember the names of quadrilaterals. Thank you, Hung, for correcting me. And remember the names of them. Finally, trigonometry. Quite tricky, but you need to memorize them. SOHCAHTOA in English, or the phrase I mentioned earlier in Vietnamese. Remember them because you will most certainly not going to be able to guess this if you don't remember them. And cotangent is basically 1 over tangent. Just flip the denominator and numerator. Next is common trigonometry values. This circle of trigonometry is to remember whether or not sine 90 is 1 and cosine is 0. Cosine 90 is 0 and cosine 0 is 1. Sine 0 is 0. All right. This is what I use it for, and I suggest you use it too, because this will come in handy only when you are specialized in physics and only when you're learning for the physics SAT, physics subject, and or else you just need it to remember whether or not sine 90 is 1 and cosine 90 is 0. That's it. Special values and its values in radians. and also areas. 2D is areas and 3D is volumes. 1D is the length, all right? And that's it. Do you guys have any other questions you need to ask? You guys have any other questions?
These whiteboards, can you like export them and send them to me, please?
Oh, okay, of course.
Thank you so much.
All right. Any other questions? So, if there's not any other question, I would say goodbye to you now. Class dismissed. Have a great day. Have a great night. Goodbye. Goodbye, everyone.
Bye.